If you were to walk into a modern classroom or browse the internet, you would often hear a curious question whispered with great seriousness. What was Einstein's IQ? The question itself reveals something about our age. We have become fond of measuring the immeasurable, of compressing the vast landscapes of the human mind into a single tidy number. It is as though we wish to place genius on a scale, weigh it, label it, and store it neatly on a shelf. But intelligence, true intelligence, is not a number. It is a living, breathing force. It is a restless spark in the mind, a gentle dissatisfaction with the obvious, a quiet refusal to accept the world as it appears at first glance. You see, the popular image of intelligence today is often tied to speed and accuracy. How quickly can you solve a puzzle? How many facts can you recall? How high did you score on a test? These are convenient measurements, and convenience has always been the friend of bureaucracy. But the universe does not reveal its secrets to those who merely answer quickly. It yields only to those who ask deeply. Albert Einstein, whose name has become almost synonymous with genius, is often said to have had an IQ of 160 or 170 or even higher. The truth is far less dramatic. No one knows. He was never given a modern IQ test. The numbers you see floating around are little more than guesses, numbers assigned after the fact, like medals pinned onto a man who never asked for them. And yet, even if such a number existed, it would tell us very little about the nature of his mind. Einstein was not famous because he could multiply large numbers in his head or recite long lists of facts. In fact, he often forgot everyday things. He misplaced keys, forgot appointments, and cared very little for routine. What he possessed instead was something far more powerful, a mind that lingered on simple questions longer than anyone else. As a young boy, he once received a small compass. When he saw the needle move, always pointing in the same direction, he was astonished. There was no visible force pushing it, no hand guiding it, yet it obeyed something unseen. That small mystery stayed with him. He did not simply accept it as a trick of nature. He wondered about the invisible laws behind it. This is where intelligence truly begins, not in the ability to answer, but in the courage to wonder. Many of Einstein's teachers did not see him as extraordinary. He was quiet, slow to speak, and uninterested in rote memorization. In a system that valued obedience and repetition, he seemed unremarkable, but inside his mind, entire universes were forming. While others solved the problems in their textbooks, he was asking questions about time, light, and space itself. Imagine two students. One memorizes a formula quickly and scores full marks on an exam. The other stares out the window, wondering why the sky is blue or what would happen if time could slow down. The first student may receive praise and high grades. The second may be labeled distracted, but history has shown us again and again that the second mind is often the one that changes the world. Intelligence in its deepest sense is not about storing knowledge like books on a shelf. It is about rearranging those books into new patterns, connecting ideas that have never met before. It is the ability to see relationships where others see only fragments. Einstein once said, imagination is more important than knowledge, for knowledge is limited, whereas imagination encircles the world. This was not the boast of a dreamer who ignored facts. It was the insight of a physicist who understood that every great discovery begins as a question, a picture in the mind, a strange possibility that refuses to go away. When he developed the theory of relativity, he did not begin with equations. He began with a question: what would the world look like if I rode alongside a beam of light? This is not the kind of question that appears on an IQ test. There is no multiple choice answer. There is no timer counting down the seconds. There is only curiosity, imagination, and patience. And from that simple question came a revolution in our understanding of the universe. So when people ask, what was Einstein's IQ? They are really asking the wrong question. It is like asking, how tall was Beethoven's music? Or how heavy was Shakespeare's poetry? The measure does not fit the thing being measured. Einstein's true genius lay not in a number, but in a habit of mind. He was willing to think slowly in a world that valued speed. He was willing to look foolish by asking simple questions. He was willing to sit with a mystery for years, even decades, without forcing a quick answer. In a sense, his intelligence was not a peak on a graph, but a direction always moving toward deeper understanding. And perhaps that is the most important lesson hidden behind the myth. Of Einstein's IQ, genius is not reserved for those with special numbers. It lives in anyone who dares to remain curious, who refuses to stop asking why, even when the world seems impatient for answers. For in the end, the universe does not care how high you scored on a test. It reveals its secrets only to those who are willing to wonder. If there was one true laboratory where Albert Einstein performed his greatest experiments, it was not filled with glass tubes, wires, or ticking instruments. It had no walls, no doors, and no windows. It existed entirely within the quiet theater of his mind. Einstein called these mental journeys Gedanken experiments, thought experiments, and they became the compass that guided him through the deepest mysteries of the universe. In traditional science, experiments are performed with physical objects. You drop a ball to measure gravity, heat water to observe steam, or mix chemicals to watch them react. But Einstein faced questions that could not be tested in an ordinary laboratory. How do you measure time itself? How do you test what happens near the speed of light? There were no machines fast enough, no clocks precise enough, and no laboratories large enough to perform such experiments in reality, so he turned inward into the realm of imagination. Thought experiments are not fantasies, they are not daydreams without discipline, they are precise, logical explorations conducted inside the mind, guided by the laws of nature and the rules of mathematics. In a thought experiment, every detail must make sense, every step must follow logically from the one before it. It is science. Performed in the imagination, but with the seriousness of reality. As a young man, Einstein asked himself a simple but revolutionary question: what would happen if I chased a beam of light? Imagine for a moment that you could ride a bicycle fast enough to keep pace with a ray of light. You pedal faster and faster, approaching the ultimate speed of the universe. What would you see? According to the physics of his time, you might expect the light to appear frozen beside you, like a wave standing still in space. But this created a contradiction. The laws of electricity and magnetism, as understood then, said that light must always move at the same speed. It could not stand still. The universe, it seemed, refused to behave as common sense expected. Einstein held this contradiction in his mind for years. He did not rush to solve it. He let the question grow like a seed planted in the soil of curiosity, and slowly a radical idea emerged. Perhaps the problem was not with light, but with our assumptions about time and space. This is the power of a thought experiment. It does not simply answer questions, it reveals that the questions themselves may be wrong. Another famous mental journey of Einstein's involved an elevator. Imagine you are inside a sealed elevator, floating in deep space, far from any planets or stars. Suddenly, the elevator begins to accelerate upward. You feel yourself pressed against the floor. A ball released from your hand falls downward. Everything behaves exactly as it would if you were standing on Earth under the pull of gravity. Now imagine the opposite situation. The elevator is standing still on Earth and gravity is pulling everything downward. Again, the ball falls to the floor. Your body feels its weight. Inside the elevator, you cannot tell whether you are being pulled by gravity or pushed by acceleration. From this simple mental image, Einstein arrived at a profound conclusion: gravity and acceleration are deeply connected. This insight eventually led to the general theory of relativity, where gravity is not a force in the traditional sense, but a curvature of space and time itself. All of this began not with a machine, but with a quiet thought. Thought experiments gave Einstein freedom. In his mind, he could ride beams of light, float through space, or fall endlessly in an elevator. He was not limited by technology or materials. The only limits were logic and imagination. But imagination alone is not enough. Many people can imagine strange things, but Einstein's thoughts were disciplined. Each scenario had to obey the known laws of physics. If a contradiction appeared, he did not ignore it. He treated it as a clue, a sign that something deeper was waiting to be discovered. In this way, his imagination was not an escape from reality, it was a deeper engagement with it. The beauty of thought experiments is that they are available to everyone. They require no expensive equipment, no laboratory, and no special permission. All you need is a curious mind and the patience to follow an idea wherever it leads. Einstein once said that he rarely thought in words. Instead, he imagined pictures, scenes, and movements. Equations came later as a way to express what he had already seen in his mind's eye. The mathematics was the language, but the thought experiment was the story. This is why his intelligence cannot be reduced to an IQ score. His greatest tool was not speed or memory, but imagination guided by logic. He did not just solve problems, he reshaped the very way problems were understood. When you picture Einstein, you might imagine a man at a desk scribbling equations, but in truth, many of his greatest discoveries happened while he was walking, daydreaming, or staring into space. To an outside observer, he may have seemed idle, but inside his mind, entire universes were being built and rebuilt, thought experiments remind us that the universe is not only out there among the stars, it also exists within the quiet depths of our own thinking. With curiosity as our guide and logic as our compass, we too can explore its mysteries one idea at a time. The world, as most people see it, is a comfortable place. The sun rises in the morning, the clock ticks forward, and objects fall when dropped. These things appear so natural, so predictable, that we rarely stop to question them. We grow up surrounded by such patterns, and slowly they become invisible to us. What is familiar begins to feel permanent. What is common begins to feel true. But every great scientific revolution has begun with a person who dared to look at the obvious and ask, is this really so? Before Einstein, the universe seemed almost completely understood. For over 2 centuries, the laws of Isaac Newton had reigned supreme. They described the motion of planets, the fall of apples, and the swing of pendulums with astonishing accuracy. To most scientists of the late 19th century, physics appeared nearly finished. Only a few small details, they believed, remained to be polished. It was as if humanity stood in a grand palace of knowledge, convinced that the structure was complete. The walls were solid, the roof was secure, and the foundations seemed eternal. But Einstein, with the gentle restlessness of his mind, felt a faint vibration beneath the floor. Something somewhere did not quite fit. He was not driven by a desire to overthrow Newton or to make a name for himself. He was driven by questions, simple, almost childlike questions that others had stopped asking. One of these questions was about light. Scientists already knew that light traveled at a very high speed, but what would happen if you moved alongside it? Would it appear frozen? Would its waves stand still, like ripples in a pond that had suddenly stopped moving? At first glance, this seems like an odd and perhaps unnecessary question. Most people would simply accept that light behaves as it does and move on with their lives. But Einstein's mind refused to let the question go. It lingered like a quiet melody that repeats itself until it demands attention, according to the physics of the time. If you chased a beam of light at the same speed, it should appear motionless beside you. But this created a contradiction. The equations of electromagnetism, those elegant formulas describing electricity and magnetism, insisted that light must always move at the same speed. It could not stand still. Here, in this small inconsistency, lay the seeds of a revolution. Many scientists were aware of this problem, but they treated it like a minor crack in an otherwise perfect wall. They assumed the solution would be small, technical, and unremarkable. But Einstein approached it differently. He did not patch the crack. He asked whether the wall itself had been built on the right foundation. He began to question something even more basic, time itself. For centuries, time had been considered absolute. It flowed the same way for everyone, everywhere, like a universal river carrying all events along its current. Whether you were on Earth, on a train, or on a distant planet, the seconds were thought to pass at the same rate. But what if this was not true? This was a dangerous thought, almost heretical in the world of classical physics. Time was supposed to be the one thing you could rely on. It was the silent stage on which all events took place. To question time itself was to question the very structure of reality. Yet Einstein did exactly that. He imagined a simple scene, a train moving at high speed along a track. Two bolts of lightning strike the track at the front and the back of the train at the same moment. An observer standing on the ground, halfway between the strikes, sees the flashes at the same time and concludes that they were simultaneous. But what about a passenger sitting inside the train, also halfway between the front and the back? As the train moves forward, the passenger is carried toward the flash at the front and away from the flash at the back. Light from the front strike reaches the passenger sooner than light from the back. To the passenger, the two flashes would not appear simultaneous. This simple thought experiment led to a shocking conclusion. Simultaneity is not absolute. Two events that appear simultaneous to one observer may not appear so to another. Time, it seemed, was not the universal river everyone had imagined. It was more like a landscape that could stretch, bend, and shift depending on how you moved through it. All of this emerged because Einstein dared to question what others took for granted. His genius was not in knowing more facts than everyone else. It was in noticing that the obvious assumptions of physics were not as solid as they appeared. He treated the familiar with suspicion and the simple with respect. There is a quiet bravery in this way of thinking. It is easy to accept what everyone else believes. It is comfortable to follow well-worn paths. But to question the obvious is to step into uncertainty. It is to admit that what seems certain may, in fact, be an illusion. Einstein once remarked that the important thing is not to stop questioning. Curiosity, he believed, has its own reason for existing, and in his life, curiosity was not a passing interest, it was a guiding principle. He did not rush. He did not chase quick answers. He allowed questions to stay with him for years. He let them mature, like wine aging in a cellar, until they revealed their deeper meaning. From these simple questions about light, time, and motion came the theory of relativity, a new understanding of the universe in which space and time were woven together into a single fabric. This theory changed not only physics but our very sense of reality, and yet at its heart it began with something almost childlike, the courage to ask, what if what everyone believes is not quite true? In that question lies the essence of genius, not the possession of answers, but the willingness to doubt the obvious. For sometimes the most profound discoveries are hidden not in the complex or the obscure, but in the simple things we have stopped noticing. If you listen to the stories people tell about genius, you might think it is something like a lightning strike, a sudden flash, a moment of brilliance that appears out of nowhere, illuminating everything at once. In these stories, the genius is a figure of effortless brilliance, someone who sees instantly what others cannot, someone for whom solutions arrive as naturally as breathing. But the truth is far quieter, far more human, and perhaps far more encouraging. Albert Einstein, whose name has become the symbol of intelligence itself, was not the perfect student. He did not glide effortlessly through the educational system. In fact, he often found himself at odds with it. The schools he attended valued discipline, memorization, and obedience. They rewarded those who could repeat information quickly and accurately, but Einstein's mind moved differently. He was not interested in memorizing facts simply because a teacher demanded it. He wanted to understand the why behind everything, and because of this, he sometimes appeared slow, distracted, or even defiant. There is a famous story, perhaps exaggerated, but meaningful nonetheless, that one of his teachers told him he would never amount to anything, whether or not those exact words were spoken. The sentiment reflects a deeper truth. Einstein did not fit the mold of the ideal student. He was not the fastest, not the most obedient, and not the most conventional. And yet he became one of the greatest thinkers in human history. This alone tells us something important. Genius is not always visible in early test scores or classroom performance. Sometimes it grows quietly, like a tree whose roots are deepening beneath the soil while nothing seems to happen above the ground. After finishing his studies, Einstein struggled to find a university position. He sent letters to professors, hoping for an academic job, but received little response. Eventually, he found work at the Swiss Patent Office in Bern. It was not the kind of job one imagines for a future scientific legend. He spent his days examining technical patents, reading descriptions of electrical devices and mechanical inventions. To many, this would have seemed like a dead end, but Einstein treated it differently. The patent office gave him something precious, time, time to think, to reflect, to explore ideas at his own pace. Each day, after finishing his duties, he would return to the questions that had occupied his mind since his youth. He thought about light, about motion, about time itself. These were not questions that could be answered in a week or a month. They demanded years of patient reflection. Imagine holding a single question in your mind for 10 years, not just occasionally, but consistently returning to it again and again, turning it over like a stone in your hand, examining it from every angle. This is what Einstein did. He was not the fastest thinker, he was the most persistent. In 1905, while still working at the patent office, he published a series of papers that would later be called his Annus Mirabilis, or Miracle Year. In a single year, he wrote groundbreaking papers on the photoelectric effect, Brownian motion, special relativity, and the famous equation equals 2 to the outside world. It may have seemed as though these ideas appeared suddenly, like a burst of inspiration. but in reality they were the result of years of quiet thought, long walks, and endless reflection. Einstein himself once said, "It's not that I'm so smart, it's just that I stay with problems longer." This was not false modesty, it was a sincere description of his method. While others moved quickly from one problem to another, Einstein stayed. He lingered, he allowed questions to take root in his mind and grow slowly. He was not in a hurry to produce answers, he was more interested in finding the right ones. There is a profound lesson in this. Our world often celebrates speed. We admire those who can respond instantly, who solve problems in seconds, who appear effortlessly brilliant. But many of the greatest discoveries in history were not made by the fastest minds, but by the most patient ones. Talent is like a spark, but persistence is the fuel that keeps the fire alive. Without persistence, even the brightest spark fades quickly. With persistence, even a small spark can grow into a flame that lights the world. Einstein's life shows us that struggle is not a sign of failure. Difficulty, confusion, and long periods of uncertainty are often the companions of deep thinking. When you are working on something truly important, the path is rarely smooth or quick. There were times when Einstein doubted himself, times when his ideas were ignored or misunderstood, times when he faced professional and personal challenges, but he did not abandon his questions. He continued to think, to imagine, and to search. And in the end, it was this persistence, not a magical IQ number, that allowed him to reshape our understanding of the universe. Perhaps this is the most comforting truth about genius. It is not reserved only for those who shine early or score highest on tests. It belongs to those who refuse to give up on their questions, who are willing to stay with a problem long after others have moved on. For in the quiet persistence of the human mind lies a power far greater than raw talent alone. If you were to search for a single thread that runs through the life of Albert Einstein, from his childhood to his final years, you would not find a number, a test score, or a list of achievements. You would find something far simpler and far more powerful: curiosity. Einstein himself once said, "I have no special talent, I am only passionately curious." At first, this sounds like modesty, perhaps even an exaggeration. After all, the man who reshaped our understanding of space, time, and energy surely possessed something extraordinary. But when we look closely at his life, we begin to see that this statement was not a polite gesture. It was the truth as he understood it. Curiosity was the engine of his mind. As a young boy, Einstein received a small compass from his father. To most children, it might have seemed like a simple toy, but to him it was a doorway into mystery. The needle always pointed in the same direction, no matter how he turned the compass. There was no visible force, no hand guiding it, and yet it obeyed something invisible. This small experience left a deep impression on him. He later said that it was one of the moments that awakened his sense of wonder about the world. The compass did not give him answers. It gave him questions, and those questions stayed with him. Curiosity, you see, is not about knowing. It is about wanting to know. It is the gentle dissatisfaction with easy answers. It is the quiet voice in the mind that asks, but why? Even after everyone else has moved on, in many educational systems, curiosity is often overshadowed by performance. Students are trained to seek the correct answer, to pass exams, and to move quickly from one topic to the next. But Einstein's mind did not work that way. He was less interested in the answers themselves and more interested in the questions that produced them. When he studied physics, he did not simply memorize formulas. He asked what they meant. He wanted to see the reality behind the symbols. A formula to him was not just a line of letters and numbers. It was a story about how the universe behaves. For example, when he encountered the laws of light, he did not stop at the equations. He imagined what it would be like to ride alongside a beam of light. This question, born purely out of curiosity, eventually led to the theory of relativity, and that theory, in turn, changed our understanding of time, space, energy, and the cosmos itself. All of this began with a simple question. Curiosity is powerful because it has no fixed destination. It does not follow a straight path. It wanders, explores, and sometimes gets lost. But in getting lost, it often discovers something entirely new. Einstein's curiosity was not limited to physics. He was interested in philosophy, music, politics, and the nature of human existence. He played the violin not as a professional, but as someone who felt deeply connected to music. For him, music and science were not separate worlds. Both were expressions of the same human desire to understand and experience beauty. He once said that the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. This statement reveals something essential about his character. He did not see mystery as a problem to be eliminated. He saw it as a treasure, a source of inspiration. Curiosity thrives in the presence of mystery. If everything were obvious, there would be nothing to explore. It is the unknown that invites us forward, that pulls us into deeper understanding. But curiosity also requires courage. To be curious is to admit that you do not know. And in a world that often rewards certainty and confidence, this can feel uncomfortable. It is easier to pretend to know than to openly wonder. Einstein, however, was not afraid to admit uncertainty. He embraced it. He allowed himself to live with unanswered questions for years. He did not rush to conclusions. He trusted that the act of questioning itself was valuable. This is why curiosity is the true measure of genius. It is not about how much you know, but about how deeply you want to know. It is not about having all the answers, but about asking the right questions. A person with a high IQ but no curiosity may solve problems that already exist, but a curious mind creates new questions, new paths, and new worlds of understanding. Curiosity is what transforms knowledge into discovery. Einstein's life reminds us that the universe is not just a collection of facts to be memorized. It is a vast, unfolding mystery, and our role as thinking beings is not merely to observe it, but to wonder about it. In the end, Einstein's genius was not locked inside his brain as a number. It lived in his questions, in his imagination, and in his lifelong sense of wonder. And perhaps the most beautiful truth of all is this: curiosity is not reserved for geniuses. It is something every human being is born with. The only question is whether we choose to keep it alive.